I'm Anil Kumar, sharing with you an excellent technique of writing domain and range of square root function directly from the equation. So that is going to save a lot of time for you. Basically, you know y equals to square root of x is a function which could be sketched as, let me show you the sketch, and then we'll write domain range of this function from the sketch, and thereafter we'll actually use transformations of the equations to write down domain and range. Now, square root of x is always positive. It is in quadrant 1, right? So this is your x-axis, that is y. So the domain for this function, as you know, is x belongs to real numbers where x is greater than or equal to 0, and the range is y belongs to real numbers which is also greater than or equal to 0, right? So that is to say that the function is in quadrant 1. Now, in test papers, most difficult question to answer is domain and range of transformed square root functions. So we are going to take those examples now and then write down their domain and range. So let me begin with one. Let us say f of x equals to square root of x plus 2. Now this is a very simple function. What we notice here is that there is no change in the range, since the y, the parameters which affect vertical stretch or translations are not affected. The only change is in the x, and here so the range is same, however the domain changes. To find the domain of this function, we can use inequalities. Within the square root, we know that x plus 2, this expression, should be greater than or equal to 0, and that gives you x as greater than or equal to minus 2. And therefore, here the domain is going to change, and it is going to be x greater than or equal to minus 2, right? The range will remain same as in case 1. That is, y value will be always greater than or equal to 0, right? Now, let me consider a few complicated cases, right? So we'll consider a few complicated cases and understand how to write their domain and range. So let me now involve both vertical and horizontal transformations. So if I have this function as half square root of, let us say, 2x minus 3, and here we have minus 1. In this case, what happens to domain and range? Now we'll apply the same strategy for domain, that is to say that 2x minus 3 should be greater than or equal to 0. Solve this inequality, that is 2x should be greater than or equal to 3, or x is greater than or equal to 3 by 2. So we get domain. For range, what we notice here is that the y value has been translated 1 unit down, right? Vertical stretch and compressions really do not affect the range, right? So think about pulling the graph 1 unit down. So range, we have seen, has been modified, and now we can write domain and range for the function as domain being x belongs to real numbers where x is greater than or equal to 3 by 2, or you can write 1.5. The range in this particular case will be y belongs to real numbers, but y is greater than or equal to minus 1, right? So it is this value which changes the range, right? Now we will see how it may change if we have a reflection also. So let me take another example, which is, let us say h of x equals to minus 2 square root of 5 minus x, and let's take plus 1 here. Now in this case, you can say that the domain will be the interior of the square root should be positive. So 5 minus x is greater than or equal to 0, and that gives you that x, bringing x, okay, let me solve like this. Take x on this side. So it'd be minus, let's say 5 is greater than or equals to, take x on this side, that's simpler, x. So x is less than or equal to 5. So x is less than or equal to 5 becomes the domain for this particular function, right? As far as the range is concerned, what we notice here is that there is a reflection. So this reflection indicates that instead of moving upwards, the graph will be decreasing. Do you see, this is kind of decreasing. So it is going downwards from 1. So the range, you notice, is that y will be less than or equal to this value 1. Less than this time, since this sign is negative. You get an idea, correct? Now here is a test question for you to write domain and range. So let me use another function, which is, let us say, p of x as equal to. So I'm combining all these things, so it's a minus half square root of, let's say, minus x plus 2 minus 3. So if that is my function, then what should be the domain and range? You can pause the video, answer this particular question, and if you get the right answer, that means you have understood the concept, right? So let us work it out the way we did earlier. So let me just draw a line and use this space to find the answer. So first thing we'll do is, within the square root, it should be positive or non-negative, right? 0 or positive or non-negative. So we write minus x plus 2 should be greater than or equal to 0. So 2 is greater than or equal to x, right? So that gives us the domain. Domain for this function is x belongs to real numbers where x is less than or equal to 2, right? To find range, what we notice, this is reflection on x-axis, correct? And vertical translation 3 units down, correct? So these two combined, that shows it is decreasing, not increasing. We are very clear that y is less than, and less than this value, minus 3. Therefore the range in this particular case will be y belongs to real numbers where y is less than equal to minus 3, right? So that is a value where the graph gets translated to and then goes downwards because of this minus, and therefore the range will be y belongs to real numbers where y is less than equal to minus 3. I hope this video will help most of my subscribers who have been struggling to find correct solution for domain and range of square root functions. I'll take a similar one for other functions also, and I hope this series really helps you a lot. I'm Anil Kumar. You can subscribe my videos, send requests, and I'll gladly answer them within no time. Thank you and all the best.